Welcome to this webinar. So this webinar is organized by Hamad bin Khalifa University in collaboration with Ministry of Transportation and Communications. So my name is David Yang, and today I'm going to present data analytic tools for COVID-19 applications. So before I start, I would like to mention that this webinar contains some research results which are supported by QNF grants under the Rapid Response to COVID-19 program to 117. So this is me. I'm associate professor in Division of ICT, Information and Computing Technologies. The ICT division belongs to the College of Science and Engineering. So we have, at the moment, 5 degree programs, including 3 master programs related to data science and artificial intelligence. So I have been teaching those programs since I came here in 2014. So I also supervise students since the first batch. So now let's come to the outline today. So the main topic is that how can data analytic tools help us fight this pandemic? As we all know, this pandemic has brought a lot of inconvenience as well as economic damage to our world, and also some patients have been suffering from the disease. So how can we help as a data scientist? So one good thing about data scientists is that we can easily work at home with a computer, and we can connect to the cloud for processing, and then we can build our software and release this on the mobile platform such as Android or iOS devices. So as example applications, so we can predict and visualize general trend in this pandemic scenario, and we can also help the medical doctors diagnose the disease from certain check results. In this webinar, we'll focus on X-ray and CAT scan results. And third, we can help patients to understand their own health condition. So this is an often neglected subject because most of the data analytics focus on the medical professionals, and we have a different angle because I had some past experience about this before. I got quite confused when I stayed in hospital. So I believe that tools like this, especially aided with data analytics and artificial intelligence, can help the patient understand his conditions and disease progression much better. And lastly, artificial intelligence and big data tools can help us predict the disease progression. So for example, in the first day, we have observed that patient has this and that symptoms with this and that check results. Day 2, we have some other information coming in, and day 3, we have more information, and so on. So how can we predict the next few days? Will the disease get better or will that get worse? So those could be done based on the past information about other patients and see how the recovery progresses. In particular, today I'm going to show you 3 demos about data analytic tools relevant to COVID-19 applications. The total duration of this webinar is going to be 45 minutes. So I cannot show you a lot of details, but fortunately, I have put the links on the resources you can access, including video demos and also demo websites. Okay, so the first demo I'm going to show you is a website which I use every day myself. And this website predicts the total number of confirmed COVID-19 cases. The second demo I'm going to show you is some educational materials I've been working on. So these are video tutorials published online on YouTube that shows you how to build an end-to-end solution to diagnose pneumonia. And the third demo I'm going to show you is a research topic about how you enhance chest X-ray image quality with computer vision techniques. So now let's start with the first demo. So the demo site is this one with a link here. So you can put this link on your web browser window and you see what I have done so far. So this demo site has been online since May 14th, 2020. It was built by 2 HBKU students and they have graduated. So strictly speaking, they are not students anymore. So they have obtained their master's degree. And one of them worked with me as a research assistant for my research project. So this website was online since May. So as you see on this website, it has results since March. So everything before May 14th are just simulations, which means we already know the results and we are fitting a model based on existing data. On the other hand, everything after May 14th, which is roughly here, are real predictions. So every day we make predictions for the coming 7 days about the number of cases, and you can check the results and compare them with the real numbers. And also every day we update the model. So so for example, on May the 14th, we actually predicted the trend going up all the way to 2,000 cases per day. But at that time, we were not able to predict government action. So at some point, the government places major actions. For example, on this date, the government has a restriction that everybody must wear a mask when going out. And this has a dramatic effect on the number of cases for confirmed COVID-19. Basically, the next day prediction is as it is, and the distant future predictions are updated as new data come in. So the main technology for this prediction model is called the SAR model. So SAR, successful, infectious, and recovered. So 3 types of people. So the first type are the people who have a chance to be infected by the disease. The second type, which is the I, stands for people who already have the disease and they are actively infecting their neighbors and surrounding people. And the third type are the recovered. So they do not infect other people anymore because they had the disease and they have recovered from that. And furthermore, since they already have the disease, they are immune to it for at least a period. So some research have indicated that this immune period will last for 1 or 2 years, or maybe even longer. So those will not spread the disease, and they will not get the disease. So the main mathematical tool here is called Bayesian inference. So Bayesian inference means you have a model, and you retrofit some parameters of the model, and then the model can predict the future numbers. And also a very important part is the effect of government actions. So as I mentioned before, here around this date, the government has a major action, which is to restrict public gathering and to mandate the people to mandate the use of facial masks. And after that, the number of cases dropped a lot. So now let me take you to this demo site. So this is our demo site. As I mentioned before, I actually use this myself every day. So first of all, it shows you the number of new cases, and those numbers are directly from the Ministry of Public Health. So there are accurate numbers. So every day I look at this number, and it's updated in time. So whenever the Ministry of Public Health updates, then we update as well. So as you see, yesterday it was very good. So the number of cases is only 693, and also the number of recovered deaths and so on. So here on this diagram, you can put your mouse here, and it's interactive. For example, here I can see that on May the 29th, it reached a peak. Okay, so I remember at this point when we were online for a few days, we predicted the peak will be relatively far, and then after the government action, we predicted the peak will be near. So it turns out our predictions were right. So here you see a band. So this band means a confidence interval. So for example, here we show a 75% confidence interval and a 95% confidence interval. So it turns out that our confidence intervals right now are rather narrow, which means we are very confident that the disease will progress like that. So it will reach a lower level, like 600 in a few days. So a very interesting observation here, which was first told me by a friend who is a medical doctor, is that you see this pattern, the numbers goes up and down and up and down. Okay, so the reason is that at the moment the testing facilities are running at roughly full capacity, which means if one day the numbers are very, very high, then there will be quite a lot of patients who come back for follow-up checkups. And because of that, the number of new patients tested will be reduced. And therefore, for a short time, the numbers will go down quickly. And then after the follow-up patients have done their test, the total number of new patients tested will increase, and therefore more patients are found. So this pattern is more artificial. It basically reflects that we are near the full capacity of our testing. So here below this diagram, you can see more insights here. So for example, here it explains the effective growth rate. And now you can see the effective growth rate is below 0, which means that the disease will gradually die down. Okay, so this is our first demo. So now let's come back to our slides. So as you see before, the visualization is interactive, which means when you place your mouse on the diagram, you see a tooltip which tells you the exact number. So this technology is called the Plotly dashboard, and it is free software. Everybody can use it, and we have used this to build this website entirely. Okay, so there's no commercial software involved, so we didn't pay anything. And also you see this website, Heroku. So this website allows you to host one web application for free, assuming that you don't have a huge traffic to that. So the second demo I'm going to show you today includes video tutorials I have made in the past 3 months about automatic pneumonia diagnosis from chest X-ray images. So this effort is also made possible by my Q&F grant, RRC2 117. This is my YouTube channel. So if you go to this channel, you will see me here. And I have currently more than 50 tutorials. So some of them are long. For example, this tutorial is 34 minutes, okay, but they are never longer than that. So there are none of them is longer than 35 minutes, which means you will not spend a huge amount of time watching those videos. And some of them are very short. For example, this one is only 7 minutes. So we have used this tutorial during the semester for my course ICT 716, which is data science tools and applications. So one of the video tutorials was used as an assignment for the students, and some students have written articles about how they follow those tutorials and how they build their own systems and AI software. So those tutorials cover an end-to-end system, which means you have all the components of a complete application. So diagnosing pneumonia from chest X-ray images has been fairly advanced. There has been some discussions. For example, one of the inventors of modern deep learning, Geoffrey Hinton, has said publicly that we should stop training radiologists because AI will soon pick up. Because it's rather mature technology, we are able to build a complete AI system and with only open source tools without much research components here. So you can learn pretty much everything from this YouTube channel. In particular, our tutorials cover the environment setup, so which is one of the first barriers for newcomers because they don't know how to set up the computers and the software environment for building AI applications. We also cover AI modeling, which includes how you use the AI libraries and how to tune hyperparameters, how to write the script, and so on. Well, besides AI modeling, we also cover practical issues such as how you deploy the AI application online through a cloud-based backend. So in our video tutorials, some of them are sponsored by Ooredoo Cloud through a small grant. So, and that's why we used the Ooredoo Cloud as an example of the cloud-based backend. And finally, we cover mobile front-end development. So those can be deployed on Android and iOS devices. In particular, we use JavaScript libraries. So those libraries are easy to use. So instead of writing the complicated hundreds of lines Java and Swift codes, you only write JavaScript. And so the length will be like 100 to 200 lines. And after that, you take your model and you have a full-fledged application. So all the code involved in those video tutorials are also published in the Github repository. So this is my Github repository relevant to these video tutorials. So the source codes they are released under an open source license, and the programming tools we use in those tutorials are mainly Python with also JavaScript for the front end, but no more than that. For example, you will not be programming using low-level C to deal with the GPUs, to deal with the cloud computing platform, and so on. So for the AI libraries, we use mainly PyTorch and FastAI, which are among the most popular AI libraries nowadays. So nowadays, either you are a Google fan and use TensorFlow, or you are not a Google fan, then you use PyTorch. And many of the research project has switched to PyTorch, and FastAI is built on top of PyTorch, which makes programming really simple for beginners. For backend, we mainly use Docker, which makes deployment easy. So instead of writing scripts and cron job and so on. So now the only thing you need to do is to upload your Docker image, which is like a virtual machine. And then on the cloud backend, you select your Docker image and it is there. And you can have auto scaling, which are functionalities provided by the Redo Cloud. And also you can do automatic scaling yourself using Docker Swarm. So for front end, as I mentioned, we use React Native and Expo. So now let me take you to those tutorial websites and channels. So this is my YouTube channel. So as you see, I have very different tutorials. So this is in the reverse chronological order, which means the oldest ones are shown at the bottom. Okay, so in the beginning, I tell you how you can set up the environment. In particular, I tell you how you can set up Jupyter Notebook with a Docker image. So Jupyter Notebook is our main programming tool. So it looks like this. Okay, so you write code here, and then you immediately see the results like this. And other than Jupyter Notebook, and also I tell you how to set up the libraries such as FastAI. And after that, I have several tutorials about how you actually classify the chest X-ray images using an AI library. So in this tutorial series, I mainly use FastAI because it's very easy to use. And after that, I show you how you deploy your AI web application on the Redo Cloud. And I show you how to stress test your AI web application, which means if many users visit your site, then you suddenly have a lot of loads and you must keep up with that. So in order to keep up, you probably want to provision more nodes, or you want to increase the CPU gigahertz and the amount of memory to keep up with your workload. So I also show you how you scale your AI application with that. And after that, I show you how you can make your website secure with HTTPS. And then I show you how you can build the iOS and later on Android front end. Okay, so I will not go into the details since you can simply watch the video to see how this is done. And after after I have covered an end-to-end application, I went on to cover more advanced tutorials. So for example, we covered pneumonia detection, not just classification. We also, detection means you not only tell that this is a pneumonia case, but you also put a bounding box telling where the pneumonia is. And also we have an advanced tutorial about how you can tell viral pneumonia from bacterial pneumonia. So as we all know, COVID-19 is a type of virus, and therefore the type of pneumonia the patient got are called viral pneumonia, and there are some certain patterns about that. And I also have a tutorial about explainable AI, in which you find out why the AI thinks that this is a pneumonia case. And after that, I also have some more advanced topics. So for example, I have covered supervised resolution. I have covered how you can pre-train a mother model for our AI purposes. I have also covered how you can understand the big AI model by drawing it. Okay, so that's my tutorial website. You can find the source code here. So for example, let's go to this folder. And as you can see here, I have one file here. So this is the code for that particular tutorial. So you can either open it here, or you can open it on a separate website. Okay, so here it shows the code, and the code is explained in detail in my YouTube channel. Okay, so here, for example, I'm trying to classify X-ray images. So this class is normal. This is pneumonia, and in some tutorials I also have bacterial pneumonia and viral pneumonia. And here you see how the model is trained. Basically, I create a learner. So a learner is the AI agent that learns from existing data, and after that, it can make predictions. So here I also shows you how you can tune the hyperparameters. In particular, there's this thing called the learning rate. So this is a concept in neural networks, which you will learn in my video tutorials. So here you draw a plot, and also in the video, I tell you how you can look at this plot and find the appropriate hyperparameter value. Okay, and here we have a learning process. As you see, after 5 epochs of training, the neural network has an error rate of 0.019, which means in this case, it has less than 2% of error for diagnosing pneumonia. So basically, it tries to tell pneumonia chest X-ray images with normal X-ray images. And the error rate that the AI make is around 2%. I also have some tutorials which covers how you can improve the accuracy. For example, it is relatively easy to tell normal from pneumonia, but it is not so easy to tell bacterial pneumonia from viral pneumonia. In fact, according to some medical articles, this is even difficult for radiologists, which means the data labels are not necessarily correct, and therefore you can never get near 100% accuracy. So I have showed you how you can improve accuracy from about 15% error to around 11% error using some advanced tricks in deep neural networks. So now let's go back to our slides. So the third demo I'm going to show you is a work in progress, and our goal is to enhance X-ray image quality with computer vision tools. In particular, we use convolutional neural networks with GANs, generative adversarial networks. This work is again supported by QNF grants under the RRC program. So the application scenario is that we have an X-ray image, which might be quite blurred. For example, here you see a rather blurred X-ray image. But if you look carefully, you still see, so these are the lungs, and you see something inside the lungs. So by the way, this I believe this is a normal image without pneumonia. So those tiny textures, I believe they are blood vessels. And of course, I'm not the medical doctor, so this is just my own judgment from doing this project in the past few months. So this is the output image. As you see, it looks much sharper and more detailed. However, here, you cannot do this in an arbitrary way. You cannot say, I just sharpen all the edges. Then your results might be misleading to the patient and the medical doctor. So you have to, in particular, when we do this medical image enhancement, we make sure that the classification result is the same, which means if the AI thinks that this is a pneumonia case, then the AI should also think that this is a pneumonia case. Okay, so this is very different from traditional image enhancement in computer vision because we have constraint that we must preserve the prediction label. Okay, so the main technology here we use is called generative adversarial network. So in a nutshell, in the GAN, you have two networks. One is called the generator, the other is called the discriminator. Okay, so the generator actually generates this image from this. Okay, so this is the input of your generator, and this is your output of your generator. So what does the discriminator do? Well, the problem with generator is that the generator cannot tell what is a good image and what is not a good image. For example, here, as a human being, we see that this is sharper and more detailed, but from the computer, from the neural network point of view, those are just pixels. And the computer finds out that those pixels looks very similar to these pixels, and therefore you may think that even this is quite okay. So the discriminator basically tells the generator that what you generate is not good enough, and therefore you should improve in this and this aspect. In other words, it is a critic for the generated pictures. So the discriminator usually is a binary classifier which tells whether the image is real or fake. So as many of us have heard about deepfake, so a fake image is some image or video generated by the GAN, and the discriminator is basically a detection network that tells you whether this is real or fake. So as you see, the generator and discriminator have opposing objectives. The generator tries to minimize the distance to the real pixels, while at the same time, it tries to fool the discriminator. The discriminator tries to do the opposite. Okay, so it tries to tell whether this is real or fake. So again, it's notoriously difficult to train using normal training methods. And therefore, we follow a strategy which is called the no-GAN. So what it does is that it tries to pre-train the generator using only the images, using only the data sets without input from the discriminator. So when you do this, your results are likely to be still quite blurred. And then we stop the generator training and we continue to train the discriminator. And the discriminator will have the output of the generator as well as the original data images. And then we basically train a simple classifier. And only after those pre-training steps, we train the generator and discriminator together in order to further improve the output quality of the generator. And this completes one phase of training. And after that, we repeat this phase. Okay, so we again pre-train the generator and pre-train the discriminator and train them together. So the goal is that we try to minimize training them together as much as possible. The reason is that when you train them together, it is GAN training, it is tricky, it is slow, and it may fail. But when you do those pre-training, there are classic image computer vision CNN training. For example, the discriminator is simply a classifier, while the generator is basically an image translation module. So those are well known how to train them, while the GAN is rather tricky. Every time you have a new GAN, you have to design your new strategy. Okay, so now let me take you to some example notebooks. So those two are example notebooks from my video tutorials. So due to IP constraints, I cannot show you the things I am currently working on. So instead, I show you things I have already publicly released. So, so in these two tutorials, I show you how to do super resolution. Okay, so super resolution doesn't try to preserve the labels of the classes, but they simply try to improve the resolution of the image. So you may, so from the glance, you may think this is like impossible. So you have a low resolution image, and you want to generate a high resolution image. So you are generating new data from nothing. Okay, so let's say your given image is 100 by 100, and then you can generate an output with a size 200 by 200. So you have much more pixels than the input. And the reason this can be done is that we have a huge number of training images, and the training images tell the neural network what the images look like, and from that, the neural network automatically fill the gaps. Okay, so here you can see it has some rough steps. So first, I built the data pipeline. So get DLS means I build the data loaders. So from using a data block API. So this is actually one of the most confusing parts to a beginner. Okay, so if you are an advanced user, you'll probably focus on the training, while when you are a beginner, you'll probably focus on the data pipeline. And after that, I show you the data pipeline, and then I start to train them. Okay, so first I pre-train the generator, and after that I train the generator more, and then I show the generator results. And later on, I save the generator results to a folder, and I start to pre-train the discriminator. Okay, so which is also called a critic. So after training a critic, I build again, and I start to train them together. Okay, so you can find this material on my YouTube channel. So now let's wrap it up. So in this webinar, we have covered 3 demos. The first, I showed you how to predict the total number of cases for COVID-19 patients. The second demo, I presented my YouTube channel for AI tutorials. And in the third demo, I showed you some work in progress about enhancing medical image quality. So now let's proceed to the Q&A session. So this works as follows. So in this webinar, you cannot talk to me because your mic is muted by the event organizer. And I don't think you can chat me privately. So if you have a question, you should find it. You should type the question in the Q&A box, and then the question will be shown to me, and I will pick up the question. I will answer it here. So we have roughly 5 minutes for the Q&A. So now, if you have questions, please feel free to ask me. So, the first question is that, what's the difference between GAN and neural network and NN? Okay, so neural network is a general term. So everything we do here is a neural network. Again, it's a specific type of neural network architecture. So as I explained, in the GAN, you have 2 networks. You have a generator and a discriminator. So normally in a neural network, you have only 1 network. Okay, so here you have 2 networks that are connected, and they have opposing loss functions, which means they have different training objectives. So our main objective is to train the generator, while the discriminator tells us how good we are doing. So the discriminator will give us a loss value, and this loss will be back propagated to the generator, and the generator will adjust the internal weights and bias parameters accordingly, so that it minimizes the loss for itself, and at the same time maximizes the loss for the discriminator. So it tries to fool the other guy, and the other guy does not want to be fooled. And when the training converges, you have a situation where neither of them can improve their score. So the generator can no longer generate better images, while the discriminator cannot really tell the difference between real and fake any better. So I remember there was a deep fake challenge on Kaggle about videos. So the best deep fake detector nowadays, which is basically a discriminator, has around 60 to 70% accuracy. So nowadays, the generators are actually far ahead of the compared to the discriminators. So now let me see the next question. So are the source data for all models available to the public? Yes, they are. So the data set we use in the tutorials are all public data sets. So you can download them from those public sources. So some of them require an application process. For example, there's a data set called Mimic3. It took me 2 weeks to get that. And before applying for the data set, I have to finish a training course. So that they know I'm an ethical researcher. And after that, I wrote the application, and they reviewed and rejected the application because some certain wording problem. And then I revised and reapplied again. And finally, after 2 weeks, I got access to the data set. But they are open to the public and they are free. So another question, the SIR model is based on time series. While time series is a different topic. Of course, this is a time series, and we have time series related analysis. But here we mainly focus on the SAR model. So the difference is that when you do time series analysis, your data usually contain many time series. For example, I have the curve for Qatar, I have the curve for Germany, I have the curve for United States, I have the curve for China. Okay, so based on those different curves, then I predict what my next day is based on not only my own data but also other time series curves. So for the SAR model, the main advantage is that it's very explainable. Okay, so everything you do, I can point you to a scientific reason why we make this prediction. While time series, sometimes you use machine learning or neural networks, so they are much less explainable. But the downside is that we also utilize less information. So here, in our demo website, we mainly use the numbers from Qatar. Okay, so let me find other questions. So there are many questions here. Will you be able to share the GitHub link? The webinar will be released to the public after this event, so you can rewatch the video, and the link is on one of the slides, so you can find that link. Alternatively, you can go to my YouTube channel. There is a playlist. In the playlist description, you can find the GitHub link. There is also a question about Heroku. Is there any way to include a map? Yes, you can include a map. So the map doesn't come with Heroku. It actually comes with the visualization software. So in the past, we have used a number of visualization software. So the best we have found is called Mapbox. So Mapbox, you can use it for free for a certain number of exercises, certain number of visits. And after that, you have to pay for visits. But that limit is pretty high. So it's like Heroku. So if you don't expect a huge number of visits, like hundreds of thousands, then you are pretty much okay to use it without paying anything. So the answer is yes, there is a way to use open source. The last question I see here is that is the deep neural network for open data source generic ones? Basically, deep neural network is a method, it's a tool. So you can either use public data source or you can use your own data source. So for example, in my QNFRC project, I have some collaborators from Cedar Medicine and also from Hamad Medical Corporation. So for Hamad, we have applied for data access although this is still pending review. For CIDRA, we are also trying to follow a similar procedure, and the researcher at CIDRA has access to that data set, so he can apply the model there. So obviously you can use real world data sets, and the data set doesn't need to be public, so it can be your own data set. So one issue here is this: so when you publish your model, will that review content of your underlying data set? Well, this is a research topic which has drawn a lot of attention. So when you think about it, a neural network is just a bunch of weights and biases. Okay, so there are trained parameters. So there is no image contained in the neural network. However, there are some cybersecurity researchers who actively try to attack this. So they have found that under certain circumstances, you can reconstruct a rough picture of your training data based on the neural network weights alone. For example, if your neural network has been trained on people, then this attack can have a rough idea that that your neural network contains images of people. For example, you can find parts, body parts like the head, arms, eyes, and so on, and certain patterns. But this again depends on how you train the neural network. So different neural network architecture review different information. So some neural networks mainly judge by the shape. Okay, so I can tell this is a person because there's a head and there's a body and there are arms and legs and so on. And there are also neural networks that don't care about shape, but they mainly judge by texture. For example, I can see this is a human being because I see the texture looks like skin. Okay, so if I see skin, I know this is a human being. So so because of this, the attack I mentioned before does not work on all neural networks. So this is still research topic. Okay, so is there any recording of this topic that can be downloaded later? So as I mentioned before, this webinar is recorded and it will be released to the public later on after this event. And I also mentioned that I have a YouTube channel, which I maintain regularly. So in the past 3 months, every week I release some new tutorials, and I release them frequently for 2 reasons. So first of all, I use some of them in my teaching in the university courses. And second, because initially I have a lot to teach. Okay, so there are many things like how to set up this, how to train the basic model, and so on. So as things advance, I have less and less to say because many things have been covered by previous tutorials, and also there are things I cannot tell you because they are research projects and they are covered by IP restrictions. So, make sure you subscribe to my YouTube channel. I'm sure if you are a beginner, you will learn a lot from that. Okay, so I believe I have answered all questions. So that will be the end of this webinar. So thank you so much all for attending. So if you have questions, please contact me. And by the way, I have another webinar on the 2nd of July. So if you are interested, please join me. Thanks. And please keep safe and see you next time.